Why should we even bother? Some might say that effect system is just another way of programming to the interface. I say, well, no, maybe it's just like saying maybe a tank is a way of, it's a kind of vehicle, or a dragon is a kind of lizard. It kind of is, but it's so much more than that. So I think for me, effect systems gives me this nice precision to exactly talk about capabilities within my system, and then just like layer after layer, abstraction after abstraction, removing complexities from those capabilities with a precise decision. So just to give you a quick example, imagine that you are on your planning meeting and you see this user story. As a user with system administrator access, I can deactivate any user in my system. While your manager is already like looking for his planning poker deck, you're thinking, well, wait a minute, I probably know how to implement this, right? There's probably some LDAP system, I have to look for the access rights. Should we have a CRM system? There's a user there, but we can just delete a row in the table, in the Postgres table. We have to suspend logging, and we have to know who we are, so some sort of authentication in the system. So while your meeting is already being bike-shedded because somebody is like fighting at the other guy, you're thinking you might just implement this. And this is like any MTL implementation. The details doesn't really matter. There's a huge echo. Can we just, never mind. So the activation, you might just implement it really quickly, and it might be, calling, do I have rights? And the question, do I have rights, is just asking LDAP server for attributes and seeing if that particular right is on that list. And then I can, if I have the access right, I will deactivate the user. If I don't, they'll throw an error. And the activation is really just dropping some access rights from the LDAP server and maybe removing entity from the database. All good? Now, this is programming to the interface because the LDAP calls might be just some form of interface, whether that is a type class or whatever, whether removing Postgres, you can test it, you're all good. But the problem is that what happens if in your system the way how you authenticate changes, the way how you get access right changes? There is a lot of concerns that intertwine with each other. And while this code is easy testable now, you can write your test quite easily with your unit test, this will fail eventually. There's going to be an unmaintainable hell eventually in your system. When I see this user story, what I really see, I see three different concerns. Authentication, authorization, and account management. What does it mean to be a user? There's slowly each of those are separate concerns which I want to treat separately. But there are already some verbs that are emerging from those concerns. There's another concern that we haven't really thought about is error handling. How do I handle errors if I throw them? Each of those concerns have their own vocabulary that we can use. But now, the user story eventually is where all those concerns meet. Yes, the user story will use authentication, authorization, account management, and error handling. But all of those are separate concerns which we should think about separately. And once we have that little, so that's one dimension really. But once we have that little concern, now we want to cut it through abstraction. What does it mean to deactivate a user? It means really to drop access rights, suspend authentication, and remove the user from CRM system. Notice I'm not talking about LDAP, I'm not talking about Postgres, I'm just talking about some lower level concerns that I can now define the activation of the account using those low-level concerns. So this really is going from some higher-level language, the activate account, to some lower-level concerns like authorization, authentication, and the CRM administration. Because the activation is really dropping rights, suspending authentication, and deleting the user from the CRM system. What we really do is we express one language, one vocabulary of one language, with a set of terms from other languages. That's really what is happening. And what is a lower level language for some might be in a higher level language for someone else. An example here being, now that I want to talk about what the authorization is, I know right now in the system, authorization is described in terms of LDAP calls, because dropping a light or rights is really fetching some of those attributes from the LDAP and then dropping them from LDAP. So now I have ability to talk about authorization in terms of LDAP. I can do exactly the same thing for authentication. So one more time, this type of authentication, suspending really is just calling a suspend on the LDAP system. It's one more interpreting one language to a lower level consensus. And we can follow that for every little languages that we define in the system, that the key point is this interpretation, going from terms of one language into a set of terms, of the language that is a set of some other languages. And a really cool feature is that this compose. So if I know how to go from A to B1 and B2, and B1 from C1, C2, and B2 to C2, I can actually tell you what it means, what is A in terms of C1, C2, and C3. So in our case, the activation is described in terms of authentication, authorization, and CRM administration. We know how to talk about each of those concerns separately in terms of LDAP and SQL calls. And then lastly, we can go for account management to just calls of LDAP and SQL, which is really, really nice. And something that object-oriented programming promised, functional programming can now deliver, because different concerns, like things like authentication, if it changes, it most likely changes for the whole organization, not only for the particular project that you're working on right now, right? Low-level concerns as LDAP and SQL probably will outlive your company. You can open source it. So it's really a key feature is to slice and dice that complexity. Now, Effectful is a library that supposedly allows us to do that quite nicely. So, given that example that we saw so far, this is how you would do it in Effectful. You define a GADT, and the data constructors in that GADT are basically your terms of your language. Now, you have to sort of like lift every constructor into this value called f. That can be done with template Haskell. I'm not doing template Haskell. I'm just gonna give you just the type signatures of those functions. What you have to understand is that for every data constructor, you get equivalent function that's telling you following. I will give you a sort of a program f with a type level list of effects. That ES over there is a type level list. And what you're saying with this constraint colon greater, which is we could call it like a member, means that account management has to be a member of that list. It doesn't have to be a first element, it just has to be on that particular list. So, for example, they've activated a user account with some user ID, a valid value could be just F with a type level list with a single element on it, account management, but it can have some other effects as well. What you're saying is at least that single effect has to be on that type level list. And what that means is that on the type level list, if you look at that program, if you look at it, you kind of don't know really what it's doing if you don't look into the implementation, but you know for a fact that the things it can do are only defined in that language, account management. It can only deactivate account or create account, nothing else. If it was using some other functionality, some other concerns, it would have to explicitly state that in the constraint of that function. So F is a monad. So you can write a program like this. I create a user, I immediately deactivate this account, fair enough. But now I want to run it, right? And I have to run it in I/O. So what do? I just ask compiler. Compiler tells me, well, you have to do this, go from F to I/O. I kind of look through the library. I see something that looks kind of maybe similar. It's not really it, but I'm just going to try it, whatever. And yeah, it's giving me actually a nice error. It's telling me you forgot to handle account management. Before you can go to I/O, you have to handle account management. And remember, handling account management was really just talking about authentication, authorization, and CRM administration. So now we can define those effects the same way, and I'll just have to really quickly skip through it. So authentication, data constructors, and equivalent functions. Same for authentication, authorization, CRM admin. So all the verbs that we've seen so far are defined using F. And now I just have to do this. I have to define what it means to deactivate user using those lower level concerns. And the way you do it is you provide a function where you say, okay, the first element that I have on that list of effects is account management. and I'm just going to rip it off. It's no longer on that list. And the way you do it is you call, and you say, by the way, there have to be some other concerns listed over there, members of that list, for me to do it. And now I can call an interpret function where I pattern match on my deactivation, and now I start calling functions from that lower level concerns, dropping all rights, suspending authentication, and deleting the user. So, and create account is not covered here because we have 7 minutes. Awesome. So now, when we started with our program, that could be just an effect with 4 elements on that effect list. And now when we call this run, there's only 3 because we ripped off the account management effect. What happened was that every call to deactivate and activate, so create account and deactivate account, was transformed into calls of those other 3 effects. Now, authentication, authorization, and CM administration can be interpreted to LDAP and SQL. We can one more time define what the LDAP is and what Postgres really is, like an insert stuff and delete stat from it and whatever. I can probably do other things as well. And now I can define, yes, I have 5 minutes. I am aware, thank you. So, sorry, no, I didn't want to be mean. I'm just like trying to chill. Anyway, yeah, so now I can define authorization in terms of calls to LDAP, really, because I just need to find some attributes and drop them. And I can do the same thing for authentication, and I can do the same thing for administration, because that's just really deleting a user from Postgres. Having that, now I can, yet again, I have a bigger list of effects. Each run, each interpretation strips one of those effects and it replaces calls to functions from higher level language to calls from those level language, slightly removing the elements on that effect list. So lastly, given that I have some LDAP library and Hackage or whatever, I can provide interpretation for what it means to do those LDAP calls. See that there's one little thing here. We're saying that interpretation of LDAP requires an IO effect, IOE. IOE comes from Effectful. And what that means is that you can actually, if you have an F of IOE, you have an instance of monad IO, so you can take any IO action and lift it into EFF. This is basically what we are doing. So now we are representing LDAP calls, LDAP functionality directly to IO calls. And we do the same thing for Postgres. And now finally we can interpret LDAP and we can interpret Postgres, and we are left with a single effect, which is called IOE. And now what? Now finally we have this function, which we can call, and this function is implemented for us in Effectful library, and finally we can do this. Nice interpretation. Your program is defined in high-level language, but it's being run in low-level language concerns. You can test it quite easily. It's all fun. Right, so is it just polysemy? Yeah, kinda. Like, you'll find some, for people who know polysemy, you will find similarities. Pretty much, really much the same. Cool other features in it, which you cannot cover because 20 minutes, but there are cool features. But you're thinking, okay, so it must be slow. And you're thinking it has to be slow, right? Because, well, 2 of the things happened. Either you believe in folklore, or you see some presentation in Zurich. So folklore is really believing things without even like facts. Do Haskell have some beliefs? Yes, you do. Like some old Haskeller gave you your Emacs configuration and Nix configuration and some bunch of beliefs. One of them is the fact that MTL is super, super fast and it's like close to I/O and you should be just fine with. And probably maybe you saw this presentation and probably this slide and you're like, polysemy is so slow. But if you like really, really closely watch this presentation, listen, you will see hear some tiny little details that are really, really interesting. Anyway, there are benchmarks in Effectful that you can run. You don't have to trust slides. You can just actually run them and see the results. And they have a really nice distinction there. 3 minutes, awesome. Okay, they have one nice distinction: a shallow test and deep test. So shallow. So the benchmark that they run is a typical countdown benchmark, the same that Alexis King was using at her presentation. But the shallow ones are using the only single state effect that is needed to run the benchmark. Whereas the deep, they are more sort of closer to the real world, in which you have a bunch of effects that you have to combine at the end of the world in your main function, but your particular function is using maybe like 1 or 2 of them. So just to give you an example from that particular benchmark, the deep MTL countdown example, what it needs, it really needs this run state. But it also does, at front of it calls a bunch of run ReaderT with unit 5 times and run ReaderT unit at the end, just for fun, just doing that, interpreting some other effects that you normally have to do. Okay, so what are the results? Well, you don't really see them, do you, right? So, but let me tell you really quickly. This is fuse effects. So the reference implementation takes like 6 to 9 microseconds, whereas the fuse effects takes 1.5 milliseconds. So maybe just remove this. Now, the interesting bit is selling point number 1. While reference implementation is roughly between 6 to maybe 9 microseconds, Effectful is roughly between 9 and 50, depending on what kind of effects and tiny little details I didn't have time to cover, you're gonna use. But if you wanna take the most pessimistic interpreter, it will take 60 microseconds on average in that benchmark while running this deep stack. So I'm like completely ignoring the shallow stack because those are not really realistic. You don't really see it, but you think this must be polysemi, right? It isn't. This is polysemi. Polysemi sucks. It's like 2 orders of magnitude slower than the reference implementation. But this is your MTL, your super fast and extremely awesome MTL. It sucks even more. It's 500 microseconds, give or take. So why is Effectful so super fast? Well, you have to, why MTL fast is so super slow, you have to remember that optimizer is really, the key feature here is an ability to inline functions. And if you use MTL, you use type classes, and that is dictionary passing, and that we cannot optimize unknown calls. And if you want to know details of it, go see Zurich Hack Talk from 2020 by Alexis King. It is really, really awesome. I'm not going to cover that because we have no minutes. We have 0 minutes, but I'm really to the end. Okay, so, and MTL sucks. And if you want to know why, just click that link and read the blog post. It's awesome. Right, so why Effectful, okay, 60 seconds, I promise. Why Effectful is performing so well? Because that's really what it is. It is a new type wrapper over it's not even really a ReaderT. It's unwraps the ReaderT. It's just a function from some environment to I/O. And Effectful, what it gives you is ergonomics of polysemi with performance of ReaderT pattern. That's really what it is. ReaderT pattern that looks like polysemi. And because that's a new type, Haskell optimizer know what to do with it, just completely remove it. Because it's a non-function call, it can inline it. And when it can inline it, it can do all the beautiful things, and the code will just work really fast. Other things I would normally cover if I actually apply in the proper time for call for papers for this presentation, if I didn't procrastinate. But things to notice: all the stuff that is wrong with MTL is covered. So no longer, if you run 2 stateful effects asynchronously, you will lose effect. No longer, if you throw an error, you will not clean resources. All that is covered. There is a concept of dynamic and static dispatching, which is awesome, and I don't have to cover it. Don't have time to cover it. And it has higher order effects. If you use polysemi, if you know how problematic it potentially was, this is covered as well. Talk to me after class. Read the code base with code, the documentation, because it's really awesome. There is a nice issue number 1 when the author of the library asked some people in the Haskell community, hey, just poke this library and look for errors, and the Reddit discussion as well. That's me. Thank you for staying with me. And we are done. Thank you very much.
All right. We are really very short of time, so we have time for just one question. Who has the best questions in the whole room? Okay.
The answer is 42.
As it always is. Thank you very much.